So now I'm giving an overview about the Cossan-X software. As we have seen in the previous presentation, what we need to perform the stochastic analysis, and we have also covered the part about the history and development of the Cossan software. Now about Cossan-X. Cossan-X is, as I said before, is a graphical user interface of the Cossan software. So it provides some user interface that contain all wizard and the editor that allows the user to define the problem. So it can contain plugin to interact with the third-party solver, not necessarily finite element package, but any kind of solver. It connects with some software and core components where they have advanced algorithms and tools, and in order to perform some analysis like uncertainty quantification, sensitivity optimization, and so on. So all the input-output format are in store and in open access in a standard format. So basically you can read the input and output of Cossan software even without the Cossan software. So that means you will always have access to your data. Now, as I mentioned, this shows a screenshot of the Cossan-X. So you have a different component of the graphical user interface. The part is visualizing the results, parts that define the problem, for instance, defines some random variable, and you have a workspace that contains a summary of a collection of the part of the problem that has been defined. Has been coded in Eclipse RCP and provide a native interface on different platforms. So if you are using Linux, you have the interface of Linux. You have Windows, provide the interface of Windows machine. So I mentioned we provide help, wizard, and graphical tools to support the analysis, step-by-step analysis, and guidance for the user. So the user is always guided through the analysis. So you always get some suggestion how to perform a specific analysis using Cossan-X. So here I will just provide a short overview. So for instance, we can define the parameter of the model in a different way. We can define parameters. There are actually some inputs that are fixed values. We have a random variable, as you can see here in this slide. So for instance, we want to model a parameter h as a Gaussian distribution. So with a given mean, a given standard deviation. Here you have a preview of the probability density function and a cumulative density function of the defined random variable. You can also define a set of random variable. That is good when you want to include a correlation among random variable. You can also define a function. That means that the input of the model is a function, is defined as a function, might be like the values of the parameter times values of the random variable. You can define this kind of input. You can even define a stochastic process, basically a quantity that change over the time or over the space with a given function or correlation. And you can also have a design variable. These are inputs that are used when you perform optimization. So we want to find what is the best values of these control parameters that allows us to minimize what we call objective function. And here you can see an example of the definition of random sets of random variables. For instance, we want to define 3 random variables, and we also want to add a correlation among those random variables. And this is a possibility, can be done using Cossan software, Cossan-X and OpenCossan as well. Or you can define the random variable set using what we call a Gaussian mixture distribution. So basically, you start from some realization, some experimental values. So around each point, you attach a Gaussian distribution, and your entire multivariate distribution is a collection of this Gaussian distribution. You can find detailed explanation about the Gaussian mixture distribution on the theory part is available on our website. Then you can define the model, and the model is simple, a combination of the input parameter that has been defined before with what we call evaluator. Evaluator is a component of the software that perform the analysis. So for instance, in this example, we have an evaluator that calculated displacement of the beam. And basically, the only thing we need to do is to link the input with this evaluator. We can also define or specify that some random variables are correlated. So we add a random variable set, and we define the quantity of interest. For instance, in this case, it was simply the output of the model, or the displacement, or the cantilever beam. And a good feature about Cossan-X is you have the help integrated on the software itself. So you can ask, if you are not sure about how to define a specific part of the analysis, you have this question mark here. You click on the question mark, you open windows that you can see here, by provide an help and detailed description of how you perform the analysis and what is expected by the software to perform the analysis. And then you can also combine multiple solvers. For instance, you might have an analysis in MATLAB that prepare, for instance, the measure your model. Then you might have a C function that is basically generated the mesh. Then you have a solver performing CFD analysis. You post-process the result of CFD solver, and you pass the result of CFD solver to a finite element analysis. You can have this very complex and complicated workflow. In the same way you have performed the analysis before. And you can perform a reliability analysis by defining what we call a performance function. So basically, a performance function is simply a mathematical function that defines when the system or the component is performing well, or performing in a satisfactory way, or on the contrary, is not performed as expected. So basically, a performance function is a mathematical function that divides the output space into regions, what we call a safe region and a failure region. And then based on the result of the performance function, you can perform the reliability analysis. Again, if you are not familiar with reliability analysis, you can have a look on our website on the theory part on the training course, where we have a series of presentation and slides available that allows you to understand the meaning of reliability analysis, the performance function, safety margin, all the quantity for interest we are going to use later on. And as I mentioned before, so we also have the wizards. Wizards basically add some predefined solution sequence that we are going to use. For instance, this is some screenshot from the software that's used to perform a sensitivity analysis. Let's assume the user wants to perform a sensitivity analysis about the model. So this wizard basically have these panels that ask the user to select the quantity of interest, to select the method they want to use, which variable they want to analyze, and providing also some more details, for example, how many simulations they want to perform, and so on. And finally, we can also visualize the result in a different way. We can create histograms, we can create a scatter plot, or we can create a parallel coordinate plots. That's quite useful if you have a very large number of variables, so you want to plot all together all the variable, and you can understand how the variables are correlated, or how the inputs affect the result of one specific parameter or one specific output. And I mentioned also that we can store the result in different format. And one good feature about the Cossan-X is the possibility to export all the simulated result or the analysis in local or remote database. So we can use SQLite if you want to store the result in a local database, but you can use also MySQL or any other database if you want to store the analysis remotely or in a much more enterprise level database. And this is quite convenient because you can later on retrieve your result. You want to interested to know, okay, what was the analysis has been performed for the cantilever beam using a specific combination input parameter. You can retrieve this analysis and without redo the analysis. Saves a lot of time. And we have also a quite a detailed documentation about the Cossan software. So we have the documentation that's available in our Cossan website, it's cossan.co.uk/wiki, that you can find all the documentation is available. It's open documentation, so everyone can access, can read the documentation. And this is also accessible directly from Cossan-X. As mentioned before, so you can click on the question mark you find in the graphical user interface. You can open up an app inside the software itself. So we also have a number of tutorials, predefined tutorials. So we have 13 tutorials that are now available, and these are also available in our website, but also available directly from the software. And Matteo later on is going to show you how to actually start a new project and import a new tutorial or repeat the tutorial from scratch. So we also have a number of showcases. So basically that represents some complex analysis, but we are not suggesting the user to redo this analysis because it will take a very long time, and also we don't have necessarily the availability of the finite element model for everyone. But it gives you an overview of what we can do or what it can be done using Cossan software. So one of the most interesting feature of Cossan software is the possibility that we can interact with the third-party software. So for instance, you can generate a random realization of input parameter, and while we take this realization of input values, we basically overwrite the values of the input file of our solver. Then we perform the analysis. That will produce an output file. Then we read the output file and we collect these values and we perform some statistical analysis of all the collected results. So how is performed? So we have some interface to help you to perform this link. So for instance, this shows an example of an input file from a Nastran model. So this is typical input file of finite element analysis. So we replace numerical values with this XML tag. And that means that every time it finds the original values was 1, so we connect the values of this number with a variable that has been defined in Cossan-X. And then when you perform the analysis, this numbers is overwritten automatically. But we will see, we have a dedicated tutorial about how to perform the interaction with the third-party solver. And then also we can read the result directly from a finite element analysis. So if your finite element model or any software is performing returning the analysis is in a file, so we can read that file and we can extract the quantity of interest. As I mentioned before, so we can also access to the parallelization capability of the software. We can perform an analysis using local parallelism, so we can use a multi-core analysis. We can also have a job parallelism. That means if you have access to multiple machines, you can perform one analysis in one machine, another type of analysis in another machine, and so on. Or you can perform some hybrid analysis, perform one type of analysis, one machine using all the core in that machine, or second analysis performing in another machine, and so on. And here this also more details how you can perform the parallelization. For instance, if you need to solve, each analysis actually requires to solve n sub-analysis, or you need to n solvers, you can group the job in a different way. So for instance, a job might be, okay, I perform analysis of first solver, then the result is passed to the second solver, then it's passed to the next solver, and so on. This is called vertical parallelization. Or you can decide, I run the solver 1 for all the realization of input parameter. Then when all the analyses are completed, I analyze the second solver, and so on. And this is called horizontal parallelization. Or you have the granular parallelization, when you have one job that corresponds to one realization of the solver 1 and is performed on one machine. Another realization of the solver 1 is performed on a different machine, and the solver 2 is only performed when the solver 1 has been completed and the data are passed to the proper solver. This is a little bit probably more advanced, so if you are interested to the parallelization in Cossan software, so we can discuss later on after this presentation. Here I provided an overview about the tools and algorithms that are available in Cossan-X. For the reliability analysis, we have access, of course, to Monte Carlo simulation, but also more advanced sampling techniques like Latin hypercube, Sobol, and Alton sampling. These are quasi-Monte Carlo techniques, but also much more advanced and efficient Monte Carlo method like line sampling, subset simulation, importance sampling. And of course, we provide the support to also first order reliability method. In terms of optimization techniques, we have availability of different optimization techniques, from gradient-based optimization techniques to gradient-free techniques like simplex. And other popular optimization techniques are genetic algorithms, stochastic ranking, simulated annealing. In terms of meta modeling, we can use artificial neural network, response surface, polynomial splines, or polynomial chaos. And finally, for the sensitivity, we have local sensitivity, so based from finite time difference or Monte Carlo method, and global sensitivity analysis using by computing Sobol and total indices, or even computing the upper bounds of those indices. So the Cossan-X is quite flexible, so it's extendable. So you can create new loops, you can create a new solution sequence by define basically your solution sequence using matter language. So you can actually use some part of matter language directly in Cossan-X in order to extend and to design a new solution capability. And good things is that you still don't need to use matter to do that. Although there are some limitations if you are not using matter, because you cannot have functions. And for the Cossan Demo version, so this is available to everyone. It can be downloaded from our website. There are some limitations compared to the full version of the software. So we don't provide the connectivity with third-party solvers, so you can only have some dedicated solver, mostly using based on MATLAB scripts. We don't provide optimization, and we do not provide the global sensitivity, but you have access to the full reliability analysis, a full uncertainty quantification analysis with the Cossan Demo version. So if you want to test the full capability of Cossan-X, so well, we can provide the access to our cluster. It's called a risk cluster, and you can connect remotely using a VNC client, and that should be available. If you are from the University of Liverpool, that is absolutely easy. Just use a mobile extern, connect to RU1 server, and then you can start Cossan-X directly. So nothing else is needed. So in summary, this presentation provide an overview of the Cossan-X, the capability to interact with third-party solver, the availability of the advanced simulation method for the treatment of uncertainty, and also the possibility to use a high-performance computing capability. So what we are going to do next is you need to follow the tutorial for getting the software. So you try to start and running the software on your machine. When this part is completed, so we will have another presentation about Cossan-X. So we will guide you through the definition of the first model in Cossan-X.